How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com.
Hey, Carl and Richard here. As you may have heard, NDC is back, offering their incredible in-person conferences around the world. And we'd like to tell you about them. NDC Copenhagen is happening August 27th through the 31st. Go to ndccopenhagen.com for more information.
NDC Porto is happening October 16th through the 20th. The early bird discount for NDC Porto ends July 21st. Go to ndcporto.com to register.
And check out the full lineup of conferences at ndcconferences.com.
Hey there. This is Jeff Fritz, the purple blazer guy from Microsoft, letting you in on a little secret about my friend Carl Franklin. You know, the guy who started .NET Rocks, the first podcast about .NET. In 2002, the guy who's been teaching Blazor on YouTube since 2020. Yeah, that Carl Franklin. Well, Carl's joined up with the folks from Code in a Castle to teach a week-long hands-on Blazor class at, are you ready? Get this, at a castle/villa in Tuscany. It's sort of a luxury vacation with Blazor learning built in. Carl's calling it the Blazor Master Class. You'll learn Blazor from the ground up, finishing the week with the ability to build and deploy Blazor applications. Since the training happens for only 4 hours in the morning over 6 days, you can bring your significant other, your partner with you, and you should, right? This part of Italy is absolutely beautiful. There's so much to see and do, and Larry and Marco from Code in a Castle are organizing daily activities both at the castle and in the area. The castle is in the Maremma, a less touristed region of Tuscany, offering both classic Tuscan hill country as well as easy access to the Etruscan Riviera with sublime local food, wine, and olive oil around every corner. Breakfast is included every day. There will be 2 communal dinners at the castle bookending the experience, and most other meals and all activities are included. And did I mention you'll learn Blazor in person from Carl Franklin? Listen, space is limited and for very good reason. This is quality training in a beautiful setting. Go to codeinacastle.com/Blazor2023. That's BLAZOR 2023 to take advantage of this amazing opportunity to join Carl in Tuscany for an unforgettable week of La Dolce Vita while advancing your programming skills in this important new technology.
Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
Man, I got a story for you.
Oh.
My new studio is coming along. Have you been seeing any of the videos I've been posting?
You know what I saw? I saw red.
Yes.
You do like the red walls.
I do. And it's the same exact fabric that I had at PWOP 1.0.
Interesting. Okay.
Yeah, the same exact stuff.
And that was really 2.0, right?
No, that was 1.0. Well, okay, 2.0, yeah, I guess.
I mean, the old State Street place you had, it was the training space first.
Yes.
Then it became the studio space, and then you built the studio space.
Yeah, you're right.
Like, you definitely went through some iterations there.
We might as well say Studio 1 was my basement in Waterford when I did Strange Communication.
So now you're staring at 5.
Yeah, I call it PWOP 3.0.
Okay, I'll buy that.
Yeah, we'll buy that. The third version is the best version anyway of everything as we know.
Yeah.
Anyway, putting in the floor in a couple of weeks. The split HVAC system is going in on Tuesday.
Nice.
And the band is going to start rehearsing there in just a few weeks. So I'm really psyched. Cool.
That's really great.
Anyway, let's start with Better Know Framework. Roll the clear music. Play.
Awesome. All right, man, what do you got?
This is something I know you're going to be interested in. You probably already know this because you know everything. But it's an article in electrek.co.
Sweden is building the world's first permanent electric road that charges moving EVs.
That's cool.
Isn't that cool?
Yeah.
And there's a picture of a bus, and it's driving over this blue strip of with charging some things in it. Magnetic charging? I don't know. You probably know.
Yeah, it's probably Q-style charging or just impedance or field-style charging, which is fine. It'll only charge so fast. But and
it's pretty smart because it doesn't have to charge really powerfully because you're constantly going over it, right?
Yeah.
If every foot you get a little bit of charge, enough to go at least a foot, then you're positive, right?
Yeah, I don't think you're going to be that net benefit, but hey, anything that adds a little range, and it stretches a bit further, so much the better. I mean, clearly this project is an experiment. They're talking 20 kilometers, right? So it's one piece of one thing. And who knows how many more they're going to do. But, obviously after their experiments, they said, hey, this piece makes sense. So we're going to keep doing this. And we'll see what happens. It's great to see, infrastructure come into play. Not to derail the conversation, but you also saw Ford signing on and now GM signing on with Tesla to do the North American charging standard. Like this.
That's cool.
Here's an interesting point. The Model T released in 1901. First gas station opens 1913.
Wow.
What did they do for 12 years?
Yeah, I don't know.
You bought your gas in containers from the chemist. That's what you did.
The chemist.
Yes. Well, what we now call a pharmacy, but basically. Exactly.
Yeah. But
to that point, watch how these things emerge. The idea of the standardized gas filler that, one gas station had different tanks for different kinds of fuel, right? You can get diesel, you can get propane.
All right. We have to do a new geek out on electric cars and electric transportation.
Perhaps. But, we are at this point now where it's like, hey, we want standards around this. We want these things to work correctly. So again, the experiments continue. This Electrotech article is a great example of that, of more experiments.
Well, it's a nice experiment, but will it scale? That's the question. See what I did there, Derek?
I like that. No, that's very clever. Are you the one trying to stay on subject? That's weird. I'm not used to that.
Really? All right. Who's talking to us, Richard?
Grabbed a comment off a show 1778. That's the one we did back in 2022 about pro microservices in .NET 6. That was Sean Whitesell, Rob Richardson, and Matthew Groves.
Right.
And this comment comes from Mark Essex, who said, wow, what a timely podcast. We're in the early stages of porting our monolithic web forms app, which has been in production for 20 plus years in some form, to microservices. I immediately went out and purchased the book, and I will force myself to make time to read all 408 pages. Well, I'm sure Sean and Rob and Matthew will be
might want to listen to this show first.
Yeah. I thought the discussion was so relevant and really hit on some key points that we've been discussing internally about areas of concern and issues that might arise. I'm scared to death about how to debug this thing or to test it or to ensure the same quality that we've enjoyed with our current application. Yeah. I mean, if you've been running an app for 20 plus years, like, people are pretty used to it, right? And as somebody else mentioned in the comments, I really hope we don't have to decide to go back to our monolithic app, as that would have a whole other set of challenges. So thanks so much for a great podcast. With any luck, Mark, you'll be that was a year ago, admittedly. So you're probably pretty far down the path. Maybe this show isn't timely enough for you, but here's to hoping. We're certainly having a conversation about, there is no one perfect solution for anything, and there's a bunch of ways to solve this problem. And that's certainly what this show will be about.
Yes, sir.
So, Mark, thank you so much for your comment, and a copy of Music to Go By is on its way to you. And if you'd like a copy of Music to Go By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Go By.
And you should definitely follow us on something. You can follow us on Twitter if you want to. We're there. Or Facebook, as Richard said. But the cool kids are over on Mastodon right now. I'm at Carl Franklin at techhub.social.
And I'm Rich Campbell at mastodon.social.
Send us a toot. Rudy Tooty, fresh and fruity. Okay, let's bring on Derek. We actually started the conversation before we started recording, so we'll probably pick up there. But Derek Comartin is a software developer with over 2 decades of professional experience.
He's written software for various business domains such as consumer goods, distribution, transportation, manufacturing, and accounting. Derek has a very active blog and YouTube channel called Code Opinion, which focuses on software architecture and design. Welcome, Derek.
Thanks for having me. I wanted to say I'm a first-time caller, long-time listener, but I was not sure if anybody would realize what that is.
Yeah.
Well, we get it, but it is old school.
Yeah.
Long-time listener, first-time caller. Yeah.
I love it. Well, and I'm a long-time reader of your blog, sir. I often tweet out my favorite of your blog posts.
Yes, I appreciate that.
Yeah, for sure.
So scaling in general seems like an insurmountable task when, the boss comes and says, we have to talk about scaling. Okay. Because we can't imagine to what degree we need to scale. And most companies think if they're public facing websites, for example, they think that they're going to be the next Netflix or the next Amazon or something. And so it may be completely over-architected and completely overextended. And then you have the companies that are small now, but think that they will grow to be these big companies. So we want to be ready to scale. And that may involve a lot of extra architecture the developers don't want. I mean, there's just so many gotchas in scaling. And I guess that's why we brought you on, to help clear up some of this nonsense.
It is it's an interesting topic because, like you said, there's this notion where right from the get-go, we need to decide now in stone exactly what there's going to be so we can be the next big thing, right, or that we think we might be. And I think there's just this right now, even though we've been swinging back, I feel like the last couple of years where we've been doing the kind of getting more focused on microservices, like we were talking about the comment. And I think it's viewed the wrong way. I think you can go pretty far for if you have a monolith or if you're starting that way. Mm-hmm. If you think about how you're building your app, not necessarily in a physical sense right away, but more in a logical sense, mm-hmm, how you design it that way, you can then decide how you want to scale. And there's a variety of different ways to think about scaling. I mean, I think primarily if you were to say, I don't know, 15, 20 years ago before cloud, it was a little bit more difficult in the sense that you were thinking, okay, we got to buy new hardware. And that was right, a little bit more difficult to scale up or scale out potentially. But now it's just a little bit easier, but the kind of the same thought process is still the same for me. It's thinking about just the traditional things of, are we scaling up? Are we scaling out? But they all kind of have implications about what I really call moving the bottleneck. Mm-hmm. Usually when you're changing one thing, down the road, you're likely changing something else. So right, it's kind of an evolving thing. That's why I think it's a little bit of a fallacy to think up front, we're going to create microservices, and that's going to just solve all our scaling problems. When scaling of what actually are we talking about there? Because in most times that's more of an organizational thing than it is necessarily a compute
when you
thing.
said the word microservices, I could tell that a million sphincters just tightened.
I thought I saw your eye twitch, actually, Carl, because we've got video.
Well, that was because of the sphincter tightening, I think.
Yeah, it occurred to me, it's like we should switch to microservices is like the new version of we should have written this in Ruby on Rails, right? Like it's the, hey, we can't fix this problem, so let's come up with a solution so complicated that you'll leave us alone for 6 months.
Mm-hmm. It's interesting because we were kind of alluding to this before we started, which I was bringing up months ago. I can't remember how long ago it was. There was Amazon Prime Video, had a blog post about kind of their transition from using Lambdas, AWS Lambda, and a combination of S3 and some other things. And they migrated that to just be containers in ECS. Mm-hmm. And there was seemingly kind of an uproar of various opinions, including my own, about what that really was. Which people were saying, well, they went back to a monolith, which even in their own posts they did, but I kind of said it really wasn't. And there's a lot of people claiming, how does Amazon doesn't even know, AWS doesn't even know really what Lambdas are good for. Mm. And it was just a lot of hot takes, I guess, about, okay, they had this service specifically for, I believe it was for kind of trying to determine the quality of a stream and letting the streamer know, like when quality was degrading, etc. And it initially said in the post that it wasn't designed for the scale that it ended up becoming, which is, okay, great, I guess. And they evolved it. It's like, what's so terrible about deciding, okay, well, this worked at one scale, but it's not currently how it is now in the volume that we need.
Yeah, it's funny how people want the one right way, right? Like if
Human
it doesn't
nature.
work for this, then it wouldn't work for anything, right? I mean, I read the original post, and what my immediate thought was, why were you using serverless here? Like, to me, the reason you use serverless is you have an elastic load that has to abruptly scale up a lot and abruptly drop back down. The audio video consumption on Prime Video is probably pretty high all the time. It probably goes from high to really freaking high. Like, what do they need that amount of elasticity for?
Well, those Lambdas, though, they could shut down, right?
Yeah, and that's the whole thing, right? Is it's very elastic.
But it also takes time for them to spin back up again. So that could, very few people, the first person that has to wait for that has to wait.
Yeah, and another piece of that was, from what I got from it, was just the cost and the issues of moving data back and forth from those Lambdas to S3, like back and forth, like pulling that data from there.
Yeah.
So going to ECS and being in a container, you're pulling it once. They're running their detectors. It's all at that point in memory once they fetched it once, rather than the however many times they needed to do it.
And in theory, serverless should have, if you're using serverless properly, it saves you money because you only use instances when you need them. But it's got to be the shape of the workload. Right? And I guess as they understood the shape of their workload, they could implement a lower cost solution for that workload.
Exactly. I always say context is king. Like at the starting of it, maybe, I don't know what their situation was other than what they wrote in the post. It didn't seem like initially the solution worked because it wasn't at the scale that they were headed towards and they had no intention to it. So it evolved. It's like, okay, great. You evolved it. Like, makes sense to me.
This is like saying, what? You're a teenager? Childhood is a waste of time.
Yeah.
It's a great point, and it is really like you said, it's a hot take, and hot takes in general are incorrect. Like anybody who's actually built and cared for software, like I spent a lot of time helping people scale, and you always start the conversation with congratulations, you have a good problem.
Good problem.
Enough people are using your stuff that scale matters. If nobody was using it, it'd work great.
Exactly. When you kind of, I would say, I'm making the assumption here that it's not an abrupt, oh my gosh, I need to scale like from 0 to 100. It's usually kind of, over time as you're gaining traction, if it's some type of SaaS product, whatever the case may be. And usually when that's coming up, that's when you're trying to determine what needs to scale. So like I was mentioning, it could just be scaling up kind of that app service that you're running. So let's say you're just running some web app, some HTTP API, whatever the case may be. Maybe that first step is, okay, just scaling up, giving it more resources, giving it more memory, whatever it's kind of starving on. But like I said, when doing that, usually the next step, it might not be instantly, but it might be, okay, well, now we can handle more inbound requests. So what is that going to affect downstream, right? Nowadays, it's not just usually some app running. It's app running with obviously a database, some other infrastructure. There's a lot of moving parts. And usually when you scale, when you fix that one bottleneck, let's say it's at the very beginning of that app compute, you're likely going to start seeing a bottleneck somewhere else. And that may be in some other infrastructure. Yeah. So then you're kind of tackling that piece of the puzzle.
If you need more performance, right?
Yes, absolutely. Yeah. And there's a lot of ways of handling that. I think it's not immediately, I think when people get into it and it's kind of a slow process of having to fix each individual place that may be experiencing performance issues, if you will, or you can't handle that type of load. I think intuitively people start figuring it out of what to fix where, whether it be, like I said, scaling up, scaling out, adding more instances. But I think that a bigger challenge oftentimes is more related to infrastructure that you don't necessarily, like it's not your app. So that whether that be your database and depending on what type of database you're using, right? So it's easy to say, okay, well, I'm just going to scale up my relational database. It's not so easy to all of a sudden say, okay, well, we're going to introduce a read replica
Right.
And that's just going to be no problem, right?
And that's a major re-architecting. Like that's thinking about your data quite differently. You want to talk through a read replica for folks who haven't dealt with it?
Exactly. Like it's not all of a sudden well, I always say this about caching.
Mm-hmm.
It's like, I always get the sense that there's this, people talk about, add some caching, problem solved.
Everything will be fine. Yeah.
It's like, I always like people say that cache invalidation is a hard problem. I don't think it's a hard problem. Don't get me wrong. But in the sense of an application, like these types of systems, I find it more of an issue of just dealing with a cache in general. There's so much that can go wrong with it.
Sure.
Right. So,
well, and it has direct impact on business, right? Like every airline consolidation site you've ever used doesn't check with the airlines every time they show you a flight. They've cached all of that. And every so often you're going to click on a flight for a price and then it's going to go, oh, sorry, I don't have that flight. Then maybe it's 1% of the time they're going to annoy you that way. And they've decided that's sufficient. I dealt with an inventory system that was too slow and they wanted to add caching to it. And I said, that means occasionally you're going to sell stuff you don't have. What do you want to do about that? Right. And the answer was, we put in a back order system. Mm-hmm. Like we accept the fact that we don't have it. And so we never had back orders before. We'll add back ordering. So if you've ordered something that wasn't in the cache, it was still in the cache, but was on the shelf, it's like, hey, really sorry. We put you on back order. If they choose to cancel, whatever, but at least we're doing the best I can. Right. And we literally changed the business flow to compensate for performance.
Exactly. Trade-offs, right? And a lot of this stuff is usually built into, in most cases, like if you're talking about whatever industry, I love that you brought up that example because I always said that if you oversell something like in distribution and warehousing, it wasn't a sales problem, it's a purchasing problem.
Right.
So they usually have stuff in place for this to begin with, but whether it would be a read replica that you're introducing, a cache, when we're talking about something that's, stale data and how you're going to deal with that. Mm-hmm. But even just like to touch on the cache again, it's even from a technical point of view, is it always available? Is it responding to you like you're using a cache typically because you don't want to reach out, you want to offload some of those requests from your database? But what happens when the cache isn't available or it's not as responsive as you want it to be?
Right.
Mm-hmm. Guess what you're doing? You're usually going back to the database.
To the resource, yeah.
Right. So if all of a sudden everything's sailing great one day and then there's hiccups, there's performance issues with your cache. Now all of a sudden these requests that were hitting the cache or cache misses and they're going back to your database, you just flooded your database with a pile of cache misses that it normally isn't expecting.
Yeah. Let's talk through the read replica model because I think it's really interesting for folks. And I don't know that there's a product off the shelf that can let you do read replica. Like you have to code for this idea that you're writing to one database that then is synchronizing to one or more reading databases.
Yeah. There's options to have some type of proxies there. Mm-hmm. So, and then rules built around that. So you can be offloading them, but it's just still a matter of if that read replica is asynchronous and it's eventually consistent, then that's more of the issue than necessarily like you need to know it.
The whole world's been taught that by Facebook because Facebook clearly uses read replicas. And when you didn't immediately see your post, you would post it again and then you see them both. And like everybody knows about that problem now just because they learned Facebook.
Yeah, I think there's definitely something to it in terms of people are a little bit more familiar with with it, whether they're technical or not. They can sometimes probably guess what's happening.
Yeah.
But still, it's not the greatest, obviously. And I think it's whether it's a read replica or whether it's a cache, that both are potentially stale at any given time. It's context specific. Most users, I would think, in your example, if they perform some write, which they may not know they're doing, but if they're performing some write and you're immediately going to provide them with some read of that write, they're expecting it.
Yeah. Mm-hmm. And there's lots of ways to cheat on that too.
Absolutely. Yeah.
Say, you just want to see your data. So I'll keep a copy of your data around to show you right away while it spends X many milliseconds getting synchronized on the back end. We're getting a little nitty gritty here, but I found the bigger thing for performance in the read replica model was that the write database A was insert only and B had minimal indexes on it. because you didn't need them. You were never going to read from them, and indexes caused a lot of the blocking and locking that then you would later synchronize, and later being milliseconds later, would synchronize to a read replica that was that only had one place of write path coming from the write database, and then did have all that indexing to optimize for read.
That, as well as, which is another option, as we're talking about options for scaling, is creating what I'll call, like, there's different ways of determining that. Calling this is like a materialized view,
right?
Creating some type of projection where that's specifically that's something that's query optimized, right? It's that kind of separating these concerns of, okay, I have these writes, like you're saying, you want them to be fast, so we're kind of offloading indexes there, that contention, and doing the same thing on that read side, which is let's optimize for reads, whether that be indexes, whether that be more denormalized, in regardless of what type of data store it is, just more structured to the way that you want to fetch that data.
Well, and you hit a really salient point. It doesn't all have to be relational databases. Like, one could argue, and I have made the argument before and on this show, that when you've received an order, which is basically a glob of objects now, making the customer wait while you decompose that in the rows and columns is kind of daft. Like, just store the object. It is the source of truth. Send the customer on their way and do your decomposition into the read system separately.
I'll take it a step further and say where we're going with this is offloading work.
Right.
So that offloading of that decomposition to whatever,
asynchronous process.
Exactly. But that cannot be just like that view and composing that view. It's actually composing the work, like actually performing the work. So like I said, like if you're placing an order, I don't necessarily need to persist the actual order and perform the payment and everything. It's, okay, here's my message, drop to a queue, do this asynchronously, where then I can perform that work. And in terms of scaling, that's like, I would say kind of I think it's a way that people immediately can think of in your system. If you're not using any type of messaging, not using queues, anything, and you want to start somewhere down the road that way, is just look at something simple that you know can be asynchronous, like an email, right? When you click that button that says do something and it performs some type of task, it's say persisting data, and then needs to send out an email. It's like nobody expects that email to be instantly there. Right. So that's kind of the immediate place you can look at your system. Where can I offload some of this work? Where can I run this asynchronously?
Yeah. Yeah. And I love the expectation part. Nobody expects it. Like they're used to, this is asynchronous. And it's going to have some latency, and that's fine.
Right.
And I think it's how you're providing it to the user, kind of in, I hate to use user experience, but it is, it's what their expectation is. Like I said, was reading your write is, do they expect to see immediately the receipt with their transaction number of their credit card? Like, not necessarily. So that just a lot of this work can happen. It's how you're presenting it to them. Thank you. We've accepted your order. We'll let you know when it's processed.
I like e-commerce systems like that. Like, okay, I've received your order. All right. We definitely have all, another email says, we've picked your product. We know we have it all now. I've billed your card. Here's the receipt. Like, and that, in a lot of ways, like, I like that better because you see it's clearly a workflow. They're not making anything up. They're validating as they go. And more importantly, we'll step off if there's a problem.
And they're using known, methods to communicate, email, text, whatever. What I don't like is when, hey, want to track your package? Install this app.
Yeah. No. Go away.
No, thanks. I don't need
no
it
spying.
that badly.
No spying. Thanks very much.
Yeah.
The queuing model is, you talk about a programming intensive modification to a piece of software, is to go from a synchronous database connection to a queued approach. Like that, it takes some time to get your head around that, but it takes time for the users to get used to the fact that all of that is now different too.
Yes, for sure. In an existing app, depending on like what we said is, depending how you're implementing it. But like I said, I think there's a lot of places that you could probably look in if you think people are listening right now thinking, where could I do that? It's just trying to find those natural places that are asynchronous.
Right.
And I think that's just an easier place to start, especially like you said, wrapping your head around it, how it's working in your system. But there's more places probably than not that are really good fits.
Yeah.
But there are some built-in gotchas with that kind of system too, such as let's just take a very simple example. You have a model and you want to add this data to the database through this model, and the model doesn't have a primary key because there's no primary key created in the database yet. You might have an identifier for that model, but it's not a database identifier. But then you can't really use it until you get that, and you get that from the database, right? The database is going to assign you and tell you what that unique identifier is. So in the meantime, you can't do any edits, you can't do any updates, and you can't even do a delete. I mean, you really kind of have to, for that record that you just created, your user is in limbo.
Yeah, oftentimes that is one. There's a bunch of gotchas here for sure. That's probably one that I think people run into most. But oftentimes the solution there is, depending on where you're making the request from, is just providing that identifier from the get-go. Right. It may not be the primary key, but it's some other way that you can look up separately with what you've generated.
Yeah.
Right. So if it's some type of GUID.
I've moved to GUIDs for primary keys instead of letting the database do it for me. I mean, anybody can generate a GUID at any time and it's going to be unique. Yeah,
exactly. It's just you're at the client, and I don't mean the client as the end user. I mean, as wherever that needs to initially make that request is essentially providing some identifier that wherever else it needs to be doing those lookups, like you said. So it doesn't necessarily need to know when the request was processed.
Right.
The example I love to use in terms of visually too is if you're in Azure, you're in AWS, wherever, and let's say you go to stop, restart, or do something with some type of resource. You know that's not happening immediately. You're not just like making that request and, oh, this VM is stopping. Like it just stopped. Like, right? Like it's an asynchronous process. You know for sure that thing behind the scenes is queuing that up for that request to be processed. Now, in terms of feedback, like we were talking about, if that is a thing where you're behind the scenes providing some identifier, it may be using, some type of WebSockets connection to get pushed back down of that update happening, which most of them do, so that you kind of get that instant feedback, but it's not really foolproof if you've ever used it before. So you are refreshing to kind of see the latest, and there's usually a little refresh button there for that purpose. But and they indicate it to you. It's like it's stopping, it's restarting, it's shutting down. It's not instant.
Yeah,
absolutely. And Derek, I'm going to interrupt for one moment for this very important message.
There is always something new from our sponsor, Text Control. As a developer, do you need to integrate PDF generation, document editing, or electronic signatures into your ASP.NET Core or Angular applications? Or you want to learn more about the differences between electronic and digital signatures? Text Control is offering a free consulting service to educate you about digital document processing and how Text Control products can help you add these features to your applications. Go to textcontrol.com/contact and request your free personal consultation.
And we're back. It's .NET Rocks. I'm Richard Campbell. That's Carl Franklin.
Hey.
And talking to our new friend, Derek Comartin, who writes this great blog posts on Code Opinion and has an excellent YouTube channel, talking about scaling the monolith. That being said, have you seen scenarios where microservices were the right choice?
I think so. I think, well, let me start by saying I can't deal with the micro part of the word there.
Yeah, it's just silly.
Yeah, it is, but
we could call it service-oriented architecture
better.
Yeah, I know. But I think it's applicable. I wish the industry would get more on thinking in terms of monolith and microservices, but rather thinking about logical boundaries and physical boundaries. I wish we could just term it that way.
Right.
So I mean by that, right, is thinking about if you're defining, like if you have some type of large system, define logical boundaries, which I say are incredibly important to do, yet they're really difficult to quote unquote get right because of what right kind of changes as things evolve.
Sure.
But it's thinking about what does your system do? Like what pieces of functionality, where's the value, defining those pieces of functionality, grouping that all together logically, and then deciding, okay, once we have all this, how do we deploy this? What's the physical aspect of this?
Right.
can this all be deployed together? Can this be all composed into a single unit? And maybe this is just deployed as a container. Maybe
even if it was built separately,
correct,
just deployed as a unit.
Yep, deployed as a unit. Maybe we are using messaging and queuing, and it's still underneath the hood using the same, like all that same code, but the entry points are different. Rather than, let's say we had our first piece of the puzzle here was an HTTP API or some web app, but there's still a queuing component to that, which could be just a separate container that's listening to whatever queuing message bus or, broker that we're using. Still using the same underlying code. So there's just this aspect of we could compose this however physically that we want to. One logical boundary could be deployed independently if it needs to scale and it has different resources.
Well, that's certainly a situation I've run into where we realized we're scaling this large set of classes, most of which are not being called in each of the scale instances. But, there's this one problem child that gets called a lot. And if we peel it out of that larger ball of goo, it'll scale. It's easier to ramp that up. It's lighter weight to do so. And the rest we don't need is a bunch of the other stuff. So it's just like pull the two part together in exchange for the complexity of now we have another security boundary. We have another API boundary. Like all of those things had to be addressed in exchange.
Absolutely. Like it's trade-offs, right? If you all of a sudden want to decide, okay, we're going to peel out this part. And a lot of this comes down to how you're coupling between these logical boundaries, right? So that's kind of a big factor in whether you're going to be able to extract something, but how you're doing that. But if you decide that is something you need to do, like you said, for scale purposes, then you have a lot of options about just in terms of how you're communicating with the other logical boundaries, whether that's something that you hopefully from the start maybe went down a more loosely coupled route, but I realize that's not always the case. But you realize that, okay, if you weren't and you were doing in-process calls, say between logical, we'll call service A and service B, and now you're going to do that over HTTP, gRPC, whatever the case, with some request response, that's latency. There's a whole lot of, that's not like, oh, we're loosely coupled now because we have two services that communicate over the network. No.
You just created a huge performance bottleneck.
Exactly.
Done.
Exactly. So that's why I said I don't love the monolith versus microservices. I'd rather the conversation was around, okay, let's define logical boundaries, and then separately, let's talk about how these things are deployed.
Right. So what are the logical boundaries? I mean, scale is one of them, but I'm sure there's others.
So the way I often think of logical boundaries, the way I describe it, because I lived in warehousing and distribution for a long time. And my explanation of this, of how to think about it is, okay, yes, you have a warehouse system. It's enormous, right? It does everything. It
does a lot of things.
It does a whole whackload of things. It runs the entire company, essentially. So what does that mean, though? Well, if you think about it, if you were just to think about the business itself, there's a lot of departments, like there's shipping and receiving, there's sales, there's purchasing, accounting, the warehouse itself, people working in the warehouse. And if you want to think of it that way, at a sense, that is a logical boundary. And that would be a logical boundary in your system. And kind of the way that I like to use to describe this is if you were working in that system and you were talking to anybody that works in that business, and you were to go to them and say, like, what's a product? They would all give you different answers because each one of them has a different concern about what a product is, right? So if you're talking to somebody in sales, they care about the price.
Right.
If you're talking to somebody in purchasing, they're talking about like the vendor cost, manufacturer. If you're talking to somebody in the warehouse, they care none of that. They just care about where is that product physically in the warehouse or warehouses. They just have different concerns. So I think that's where I think people get in trouble is thinking of quote unquote entities as there's like one singular, be all end all of a product.
Right.
But there's not. It's logically, it's the same product, but it just exists in different ways in different logical boundaries. Yeah.
And that's normal. It's always been true. It just becomes more apparent as you press against these kinds of problems.
And that's the thing is that when you think about them that way, and you think, okay, I have this subset of functionality that we're performing on, like in sales, for example, about how we sell products, their prices, their discounts, all those types of things. And you have some other, like, let's say purchasing. I was using the example and thinking about vendors. It's kind of liberating in a sense because there are different ways of thinking about it and not conflating two ideas together.
Right.
Which then in terms of your code base, you're starting to think about, okay, well, it's not just this, what I call entity services, where it has all this mixed behavior about all these things. Then you can become a little bit more focused on what the how I say is like what the capabilities are of that logical boundary.
Mm-hmm.
The biggest part is inevitably these things need to be composed in some way.
Yeah.
That represent a product. Like if a user's on a screen, they might want to see, okay, well, what's the sale price and what's the actual purchase price?
Right.
So how you're composing those things, if you're in process together, well, maybe you are just making API calls, in process from, let's use the example of you were making these things different projects within a solution. Right. Maybe it's just some interface that you're calling, some type of class that you're calling to get that data. But there's still that boundary there physically that you're doing. It's just how you wanted to then do that. If, like you're saying, if you're kind of ripping it apart, you need to be aware about when you're going ahead of this, like ahead of time. Okay, we're going to rip this out. And then we have all these in process calls. That's going to be a problem.
Yeah. Mm-hmm. Where is it going to impact things? You can't just pull it out and hope for the best. You do need to have some sense of organization and where the code dependencies actually exist. And decide if it's actually worthwhile too, right? There can be cases where it's like the performance gain is just not enough for the complexity being added.
Yeah. That's where the thing with complexity is you're getting pretty high when you don't need to, if you don't need to move stuff out of process.
Right.
It's just, I get there's this sense that moving stuff out of process or starting that way immediately, for the sake of scale is, I'm genuinely curious sometimes if people really know what they're getting into in terms of all the, like, just deployment. And I realize things like OpenTelemetry are awesome, but
not that simple.
It's not that simple.
Well, this is the developer credo. We did these things not because they were easy, but because we thought they were easy.
Yeah.
I want to hear you say that with a John F. Kennedy accent. Not because they are easy.
Yeah, easy. But, we have this terrible disease in software development where we keep calling stuff easy that clearly has never been easy. Like virtually none of this is easy. You may know how to do it, but that doesn't make it easy. Everything is effort and everything comes with a cost. And you're shifting problems around. There's no free lunch here. Not a bit.
I think it's a good way of thinking about it, is shifting problems, or like just creating, I would say creating problems. You're trying to come up with solutions, but everything we've mentioned, right, in terms of caching or read replicas and queuing, they all come with a lot of trade-offs, a lot of complexity that you're adding, that you need to be like that. It's got to come with value. Like you actually need it. And if you're unfamiliar with it, some of these things you're going to get a rude awakening.
Right. Well, that's an overhead too. If this, how long is it going to take to learn this to do it decently? But also, I don't think there's any way to predict the outcome. Like you can't do a calculus and go, hey, if we do this, we'll get sufficient performance for effort. In some ways, there's almost no way around putting out the effort to get to a point to even know this has a return. I mean, that's certainly the challenge I had with scaling anything was we're going to try this. We'll do it as quickly as we can, but we're not really going to know the results till we do it. I mean, hopefully we measured before we started so that we can measure after we've done it and say there was a return. The number of times I've seen stuff, people just do things and go, does it feel faster to you? I'm like, feel faster.
That's the thing. Brings up a good point in terms of measuring, because a lot of this now for me it's purely based on that, of knowing, just having metrics, having some type of visibility in how your system's performing besides this seems slow. It's like, is it?
It only seems slow because the CTO keeps telling me it's slow.
Yeah, everything seems slow. Nothing's quite fast enough generally.
Yeah.
Well, and is that return, right? Like, how much faster can I make this?
Yeah, I'm used to using an i9 computer that I built myself. That's just the fastest thing I've ever used in my life. And the other day, I set up a webcam using one of those little Intel mini stick computers. I had
Oh, wow.
4 gigs of RAM or something like that. And watching that thing just crawl, just sit there at a prompt thinking and thinking and thinking. And I'm thinking, we used to wait for computers like this, and we don't even realize it because they were so slow. We didn't realize they were so slow until we got something faster.
Well, I think when we move back kind of in the conversation and we were talking about, being elastic and having those options, it really is incredible now to be able to do it in terms of Lambdas in anything, even if we're talking about just the ability to scale up quickly with minimal downtime, kind of gives you that option when, even if it's just for a moment in time where you don't really know what the heck's going on and you're having issues, you can do it and at least kind of weather the storm a little bit so you can investigate what you're going to do. But I generally find most of these things, they're kind of, if you have metrics, if you know what's happening in your system, you can kind of tell slowly over time where things are going to start going south, whether like what infrastructure it is, what resources is it? Is it your app compute? Is it your database? Is it your cache? Whatever services you're using, ultimately, you can kind of start telling. But I find one of those things is usually the metrics, usually when it's somewhat too late or you don't have the foresight to know what you need to measure.
Yeah, and I mean, when you really go back and read that post by Prime Video, you see exactly that. Over time, as we measured it, we saw performance problems, we saw bandwidth problems, and we saw cost increases. Like, they didn't know when they went into this. I mean, one would argue they built it serverless because it was quick. It was an easy way to go. And it's only after it ran for a while and it got more popular that's like, now and they literally say, let's revisit architecture. Because you have that option and got great results from the revisit. Like, this is actually a good news story.
I think it was. And especially at the end of it, I believe at the end of that post, they were saying how most of the code was reused. It was just basically pulling it out of Lambdas that were how they were being invoked. Yep. And just putting it into that process that's being executed as a container in ECS. Like,
they did a platform shift. Like, this is actually wicked cool that a lot of this code was just fine. But when you shifted the platform around, and if you shifted the platform around, you got rid of a bunch of contention. It reduced costs. Like, there was all these benefits in this different architecture. Would it work for you? Dunno. You got to go measure what you're doing right now to try and compare against other architectures.
I think that's the most difficult thing. I think you alluded to earlier. It's just like, we want this cookie cutter solution that this is just going to work all the time. And it's just not the case. I
would like the one right way, please.
Yeah. It's just not the case.
It doesn't exist. It's very funny. I wish it was that simple, but there's too many different kinds of workloads and there's too many different ways that things evolve. I wonder if this was a great solution when they started.
I think it was based on how I remember it correctly. Yeah. It's like, I think their exact kind of message was, we never intended it to be at the scale that it was.
Yeah.
So
I dealt with lots of e-commerce sites like that where we thought it was only going to have this many customers and then it got all this much bigger. It's like, wow, great problem. Like, part of this is this whole, you ain't going to need it. Like, how do you go into a complex architecture having no idea if the product's really going to take off or not? Like, build it as simply as possible because delivering it is an important value too. One way to make sure it never provides value is never finish the darn thing because you made an architecture so complicated, it takes forever to get it built.
Yeah.
It is. And when we go back to the kind of the one way that this is going to work it's starting simply based on what you're aware of kind of that space. But like I said, if you focus on defining logical boundaries, trying as best as you can to understand the coupling between them, you've got a lot of options about
when you can choose.
Then you can choose how you want to do this stuff. Like you said, if there's one particular part of your system that is heavily overloaded, maybe that's where you choose to remove it. And
peel it off and run and scale it on its own and see if that's sufficient. The other thing about that good architecture, that separation of concerns, is the experiments are easier too.
Yeah. Based on experiments, I would also say that not everything needs to be created the same way.
Right.
Right. So that means that if each boundary defines how it wants to deal with storage, and that could be still the same underlying physical database instance. Let's say like, hey, we're using this relational database for the entire thing. the exact same data. We got it.
Know how to use it.
We're not going to like split ththese things up, more cost, all that stuff. Just to use the exact same instance. Could be in the same physical database, but hey, these particular tables are owned by this particular boundary.
Yeah.
Don't go start muddling in my stuff, right? Like define some type of API, how we want to exchange this if we need to.
Yeah.
But just define those boundaries. And then from there, maybe you decide later on, you know what? Like this particular boundary, the relational just wasn't a good choice here.
Isn't needed.
So yeah. So like when you're saying like experiment, it's like you get that option, right?
Yeah.
It's not like you're doing this because you want that option. It's just you're getting it it kind of is a little free lunch, and that's it. It comes at the complexity of you have to define these boundaries. It's not just one massive.
You had to think
system.
about it.
Yeah.
But also, you now that you have that boundary, it's like, hey, would this be better served in an object store instead of a relational database? Well, let's see what it takes to do that. Maybe take a little spike on it and do some experimentation. And it's like, hey, this works pretty good. I'll finish implementing it, and then let's do some benchmarks. I've added then we'll maybe deal with some of the complexity around it. Like these are fun explores too, right? Like I found I had pretty good patterns for scaling websites because I did a ton of them, and I was often right. But you'd get into more esoteric systems, more N-tier type architectures. You're like, yeah, I see that this is likely the bottleneck. I see 3 ways for us to try and scale this. I can't tell you which one's going to win. Like we've got to try.
Exactly. And I think kind of my point when I wrote this post, even some of the videos, is just, you have different ways of dealing with it.
Mm-hmm.
Right. So whether that be scaling up, scaling out, knowing where you're going to kind of move that bottleneck, move that problem, whether you're offloading work with queues, messaging, whether that be materialized views for queries. And the other point I want to make is, at least in my experience, is generally there's hot paths, right? Like, especially in big systems, I always kind of use 80-20 rule, is that you're going to have the 20% that's causing all your havoc, basically, right? And just being able to optimize those. So whether that be, never mind from an infrastructure point of view, but just even let's look at where those routes are. Like, let's look at those code paths. What can we be doing there specifically? Are we making too many round trips to the database? Maybe we're just doing something absurd where we're just hitting our database and fetching out a whole lot of nonsense that we don't need. You'd be surprised how much that happens. So it's even just, and it can be cost effective, as crazy as it sounds sometimes, is like, let's just spend some time doing this. Like, let's just look at what we're actually doing.
The real question is, do you know what 20%? Right? Or do you have to get out in the field and run it for a while to go, oh, this is the 20%. That's the problem, Charles.
I think metrics, but I think intuitively in a large system, at least in my experience, you know what that core part of functionality is generally. Sure. I think even from, if you were to ask, say, people on the business side, like, hey, in the app, where do you think the most action is at? They know it because that's what they're in most of the time, right? Like I would say there's kind of the core part of your system as well as that fringe supporting, more generic stuff. So like when I was talking about distribution, let's say like CRM or something like that. Maybe you're like, you know what? That's not a big part of our business. We have some rudimentary thing for dealing with customers. It's really not that big of a deal. Like our bread and butter is warehouse management. And that's where all the complexity is, right? So you kind of know to a degree, I think, even on the business side, they could probably give you some hints.
Well, in the web world, nobody ever went wrong tuning a landing page, because it just had so much traffic. Like it was pretty much a guaranteed win to spend some time in there. Or usually it was just, you got to a point where it's like, hey, the incremental improvement left is so small, you can't justify more time on it. There are easier wins elsewhere, but they may not be as important. It's a fun battle. It's not like there's any simple solution to this. You've got to go out and measure and feel around and hypothesize and build some tests and push a little further. But I wonder if we're speaking heresy here. Because last time I looked, there's a cloud and I just have a knob I have to turn up, right? Like, isn't there the go faster knob and everything related to cloud? You just spend more. I
mean, to it, I like, we're joking, but like somewhat, in the sense, right? It's at least being able to scale up in a lot of circumstances.
You can always shift to a larger VM, and they are perfectly willing to sell you a bigger and bigger VM these days, it seems.
Well, scaling out too is you can do that with, at least with app services on Azure. You can. It's
really trivial to add another instance.
Just to add up, scale it up.
Exactly. Like if you already are in the situation where we scale out, say maybe our web app, and we're running 3 instances, but all of a sudden things are going south, and we'll just add more instances. Yeah. But like I said. And that may work. You add 1 instance, and then all of a sudden you start noticing, like I said, downstream starts suffering, and then it just becomes cascading.
Bottleneck, or you get a back end bottleneck.
You also have to be, your code has to be able to handle spanning multiple machines.
That's an old talk I used to do, from 1 server to 2. Yeah, it's a pretty hard leap just to get to that point.
But you know what, though?
Not all one machine.
I mean, with Blazor Server anyway, which is sort of like in my wheelhouse now, if you're using their the SignalR service, it's pretty trivial. There's affinity is turned on by default. So whatever the first server that you logged into, that's the one that you're going to use for the rest of your session. And that's nice to not have to worry about that.
Yeah, I think the scale up, scale out, just with cloud, just making it so much easier is great. And I leverage it quite often when things start going south. But I guess in experience, I kind of know, okay, we got some thresholds here where I know, okay, if this is scaling out, this is when it's a little bit too far. I just can't infinitely scale out and everything's going to be great. And to that effect too, a lot of it is things that aren't even in your control. So if you're leveraging, say, some external services and you're making requests to them, I don't know, the example is like, say you're making a call to Bing Maps or Google Maps or any other service, some type of payment gateway, and you expect that to, on the happy time, it only takes like 100 milliseconds. It's fine. And then all of a sudden that thing starts taking seconds. Yeah. Right. Like all of a sudden it's, so what the heck's going on? Where what we were mentioning with metrics, that comes into play because no matter how much you scale out, you ain't going to help that.
Yeah.
Yeah. Not that simple.
So, what's next for you, Derek? What's in your inbox?
Same old thing of just creating videos and blogs that all kind of pertain to everything we just talked about pretty much for the most part.
Well, we're going to urge our listeners to go check out your blog and continue reading it. Thanks so much for spending the time with us. It's been enlightening.
Yeah, I appreciate it. This was really cool.
All right, we'll see you next time on .NET Rocks.
.NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time. Got transmitter banned by the FCC. Yes, I'm a toy boy. Life is hard.